topic. In last class we discussed about the equation of motion. Now today we will do our third equation of motion. We have done graphical method of all three equation of motion, and we discussed first and second equation by using calculus method. Okay, now we will start our third equation of motion by using your calculus method. Then how we can do this one calculus method of third equation? V square minus u square equal to 2as. Okay, so how we can solve this one equation? First, by using here this one, again our this body is moving with some velocity. Then this one velocity we are taking our v only, initial velocity of this body u only. Okay, then after some time its velocity becomes here v only with some displacement, our s displacement. Okay, so here we want to find out with a relation between velocity and displacement equation. So here need of velocity we discussed about with a two instantaneous velocity. Instantaneous velocity we can write their small change in displacement to the small time. Then acceleration we can say there is a small change in the velocity to the small time. Okay, out of these two relation, which one relation we will use, then we will depend upon your type of equation. Okay, first one equation we discussed, that is a velocity time equation. Then there we have used there the instantaneous acceleration. Second, we discussed about there s equal to ut plus half at square. This equation is our displacement, here velocity equation. Now next, our velocity displacement equation. How we can find this relation? Here with a 1-1 relation is a displacement time equation. This also we can't use. Next one relation is a velocity time equation. Here we have to remove this time, and here this one replace this time with our displacement. So how we can replace this one? A equal to, from here to there, s is displacement. Now if there is a small change in the velocity, that change we are writing there dv. In a small time, then dt, and small displacement let we are taking there ds displacement. Okay, so here we are writing there, then let an object initially moving with velocity u velocity, and finally becomes v velocity is there. Okay, so how much change in the velocity? Small change we can find by using instantaneous acceleration in the velocity in a small interval of the time. Okay, but here velocity displacement, so how we can write their displacement? Take here multiply and divide, taking multiply and divide by small change in our displacement. Okay, so our equation will be equal to a dv by dt. Then here we are multiplying and divide with our ds to ds. Okay, now next, how we can solve this one? Solve this relation with a equal to dv by dt, small change in the velocity to small time. We are multiplying and divide with our ds. Clear? So here we know about this one relation. ds by dt, we know about this one, small change in the displacement to the small time, that we can write there as velocity, that is ds by dt. Okay, so replace this value with our velocity a equal to our v dv divided by our ds. Clear? So here ds we can take this side, then here a ds v dv. Then here small change in velocity in a small displacement, but we have to find out total velocity in a total displacement. Here equation, our third equation, v square minus u square equal to 2as. Okay, why replace this time to the displacement? Because here need of displacement, not of time, that's why we replace. So here we can write there a ds equal to VdV. For the total find out, then we will take integration on both sides. Take integration on both sides for total velocity and in total displacement on both sides. So here we can write their ds to v dv. Initially if any object is moving, then its velocity we have taken with a u velocity. After some time its total velocity becomes our v only. And here how much displacement is changed? S displacement. Now we will take the integration on both sides and we will keep our limit initial to final. Here is a change in which term, then limit we will use of that term only. Here change in the displacement velocity, dv. Here displacement, initially our displacement is 0, then our velocity on this initial point is u velocity. After some time velocity becomes v at the s displacement. Okay, now we will take integration. How we can take integration? A we can keep outside from this symbol, then here we will write their ds initial to final. Okay, then again we will take integration of this one. How we can take integration? Any number will be there, then how we can integrate? Power we will add 1 in this power, then after adding 1, same downside we will write n plus 1. Okay, this is the formula of the integration. How we can solve this one symbol of the integration? By using this formula. So apply this one term on this one. Here v power is 1 there, so 1 we will add in this power like this one. After the adding, then same power we will write downside, then keep your limit as it is for initial value of velocity to the final value to the velocity. Okay, now solve this one. After this one we can solve it. Now here we can write integration of ds. I told you but in last class also how we can take integration. If ds will be there, then here we can write there s raised to power 0, because we know that if any number is power 0, then it will give you 1 only. That's why we can write like this one. So 0 is there, then its power we will add 1 in this power, and downside we will write their same power 0 plus 1. Then solve this one, then here left your s only. So integration of ds, it will be equal to your s only. So right here as equal to, then here v 1 plus 1, then we can write there v square. Downside we will write 1 plus 1, then it will give you 2 only. Then put here limit initial to final. Okay, then after the putting limit, then how we can solve it? Final value minus initial value. Here 1 by 2, then v square minus u square, final value to the initial value. So here 2 take this side, then here left here 2as equal to v square minus u square. This one our third motion by using calculus method. Okay, we discussed our graphical method and calculus method of all 3 equations. Clear to everyone? Now we will discuss better some question related with these equations. Now our first question. A particle start with an initial velocity of 2 meter per second. Okay, we discussed our 3 equation of motion. Then using these equation of motion, we will solve this question. Initial velocity given in our question 2 meter per second. Accelerate uniformly at the rate of 0.40 meter per second square. Okay, then find the distance traveled by it in the first 3 seconds. Second question, how much does it take to reach the velocity of the 9 meter per second? Okay, now here how much means here you have to find out time. First beta, if you want to solve any numerical, then we will read our question carefully. Okay, after reading this one, then we will write the formula. Which formula we can use here? Then here after the writing formula, then we will write which terms are given in our question, then apply this in your formula. Then our 3 equation of motion. First one, V equal to U plus AT. Second equation S equal to UT plus half AT square. Then third equation our V square minus U square equal to 2AS. Then out of these three equations, which one we can use here? Then first write with a given terms. Here given term here initial velocity is given. Then U we can write there 2 meter per second. Okay, along the x direction, accelerate uniformly at the rate of 4.40 meter per second square. So A we can write there 4 meter per second square. Then you have to find out distance in first 3 seconds. Our time is given your first 3 seconds. Okay, then find their S. If any body is starting from here, then initially it is moving with 2 meter per second, then it is travel beta for 3 seconds. Your time is given here 3 seconds. Then in 3 seconds, how much distance is traveled by it from here to there? This we have to find out. Okay, so check which equation we can use here out of these three equation. U is given, A is given, T given, S we have to find out. So we can use this one equation or not? S equal to UT plus half AT square. Because S we have to find out, initial velocity is given, time already given, A given. Okay, so use here S equal to UT plus half AT square. First equation we can't use because here S we have to find out, but S is not given. Third equation also we can't use beta because here need of final velocity, but final velocity we don't know, that's why we can't use third equation also. So only one equation we can use, that is second equation of motion, S equal to UT plus half AT square. U is given here 2 meter 2, time is given here 3 plus half, A is equal to here 0.1, then T square, T is equal to here 3 second, 3 into 3, it will be 9 only. Okay, solve this one, then our answer will be there, how much displacement is covered by this body within 3 seconds. So here will become 3 into 3, 6, then 0.2, then here into 9. Okay, when we will solve it, then 6 plus 0.180, then it will be give you displacement like this one. Okay, so like this one we can apply their equation in any of this one. How we can solve the second part, beta, how much does it take to reach the velocity? As initially body is moving 2 meter per second, then here asked at which time. Okay, then velocity becomes 9 meter per second. Initially our velocity is given our in your question 2 meter per second. Then after this one, how much time its velocity becomes 9 meter per second. Here initially velocity given in our question 2 meter per second. Then final velocity will be 9 meter per second. Then in how much time its velocity become 9 meter per second. T we have to find out. Then how we can find? Check our equation, which equation we can use out of these three equations. Okay, so final velocity given in our question, initial given, but acceleration is not given. Okay, and time we have to find out. Now see second question. S here given. Okay, but when we will use this second equation, beta, that will be tough as compared to the first equation. Okay, because we can find their A by using their change in velocity per unit time. Okay, so third equation we can write there V square minus U square equal to 2AS. Okay, by using this one, first we will find A because your final velocity given in this one, initial velocity is 2, final is 9, then A we can find and S our displacement. Okay, so A, how we can write there? A equal to, by using third equation, V square minus U square equal to divide by 2A. S. Okay, S is our done already in this first part. Put value of S, V final value, U initial value, solve A. Okay, after this one A, apply our first equation. Then using first equation, put value of V, U and A we have solved already by using third equation. Then your T will be there. Okay, now our next question. A bus start from the rest then moves with a uniform acceleration 1 meter per second square. Okay, uniform acceleration, read your question, then write beta which one term is given in our question. Acceleration is given 1 meter per second square. After this one covered for the 5 minutes, that body starting from the rest and moving the uniform acceleration with this one, and for how much time? For the 5 seconds. Your time is given our 5, sorry, minute, not second, 5 minutes. We can write there 60 into 5. Then it will be our 300 second. First beta check which one term is given in your SI unit or not. Okay, if not given in SI unit, then first we will convert into SI unit. Okay, so starting from the rest means initial velocity of this body we can say equal to 0. Any body starting from rest, then we will take 0 only. So then what will be speed acquired and the distance traveled by the bus. Here we have to find out how much speed. Let here bus is given. Okay, this bus we are taking initially starting from the rest given in our question. So we can write there u equal to 0. Okay, after this one 5, here time is given, it is moving with our 300. Time is given our 300 second. Okay, with acceleration 1 meter per second. Here question is there, then we have to find out speed acquired and the distance traveled by this bus within 300 second. ओके कि 300 सेकंड के अंदर इस बॉडी की वेलोसिटी क्या रहेगी. अगर ये बॉडी 300 सेकंड के अंदर यहाँ पहुंच रही है तो यहाँ आने के बाद इसकी वेलोसिटी क्या रहेगी और डिस्प्लेसमेंट इसने कितना कवर किया है. Clear to everyone? Okay, this we have to find out. Again beta we will write, if you don't know which equation we can write here, then we can write separate all three equation here. First again v equal to u plus at, then second equation s equal to ut plus half at square, then third equation we can write there v square minus u square equal to 2as. Okay, if you don't know which equation we can use for this question, then first we will write all three equation. Okay, then we will check, then out of these three equation which equation we can apply for find out this one question. Here these three terms are given and we have to find out final velocity and we have to find out displacement, how much displacement is covered by this body within our 300 second. Okay, so here final velocity how we can find? By using this equation. Check here, final velocity we have to find out. Initial given in your question, starting from the rest means initial g. A is given in our question and t already given. That means we can apply first equation. Okay, any equation beta you can apply for find out, but out of these which one is the easy equation for find out, then we will use this one, and which are given in our question, that term we can apply there. So here by using your first equation, by using first equation of motion, then we can use there v equal to u plus at. Okay, here final velocity we have to find out. Initial velocity is given our 0 only plus acceleration. Acceleration given, then 1 meter per second square. Time we have done, that is here 300 second only. Then solve it, then our final velocity will be there 300 meter per second. Always keep in your mind write SI unit. Okay, without unit we can't identify this 300. What is this? Okay, here time, distance, what is this one? So write always unit, meter per second. Means after 3 seconds, its velocity become 300 meter per second. Now your second one part, here also asking their distance. How much distance traveled by this bus from here to there? So this how we can find. Here in first equation not having anywhere distance displacement, so we can't use this one. Here in both equation having s. Yes, na, here also. Then we can use both equation, but out of these both equation, we will check all terms are given or not given in our question. So first here if we are using third equation, then final velocity solved already, that is 300 meter per second. Initial velocity given our question 0 and 2a. A already given in our question 1 meter per second. Then s we have to find out. So we can find this one by using beta this one third equation. Apply these all given terms in this equation, then our answer will be there. Here we can solve this one by this one. Then here final velocity solved already. In this one we can write there 300 square minus initial velocity is 0 equal to here 2. A is given your 1 only, then S will be this. Okay, S we have to find out, then S we can write there 9,000, then divide by it will be 2 into 1, 2 will be there, downside will be 2. Okay, then solve it, then our answer will be there, then it will be 2500, then it will give you meter only. Okay, write always SI unit. Clear to everyone? Okay, we will do in our next class, next topic. Thank you.